Hello, this is Walter Stone, and we are now in Unit 8. And Unit 8 is about square roots, cube roots, fourth roots, also working with rational exponents and solving equations with square roots, and also doing things like simplifying products and quotients of square roots. So, a lot like Unit 7, but we're working with the square roots and cube roots of numbers. So after finishing this lesson, you should be able to evaluate square roots, use the product property or rule to simplify square roots, use the quotient rule to simplify square roots, and evaluate and simplify higher roots. So our first objective here, we want to be able to evaluate square roots. So one thing we can say is that 4 and -4 are square roots of 16, because if I take 4 times 4, we get 16, and if we take -4 times -4, we also get 16. So if b squared, some number b squared is equal to a, then b is called the square root of a, and we use this square root symbol or radical to denote what's called the principal non-negative square root of a number. So we can state a positive square root of a number by using radical 16 or square root of 16 equal to 4. And if we put a negative symbol in front of that radical symbol, then we're taking the opposite of the square root of 16, so that would be the opposite of 4. So here are some examples of using the radical notation. So for the square root of 49, since 7 to the second power is 49, the square root of 49 is 7. In part B, we have that the opposite of the square root of 64 is the opposite of 8, or -8. And if we take the square root of 1/25, that's 1/5, because if I take 1/5 times 1/5, we get 1/25. And we can work with the order of operations and think of the radical as a symbol of inclusion, and we would add underneath the radical first before taking the square root. So the square root of 9 plus 16 is equal to the square root of 25, which is 5. And then if we have the square root of 9 plus the square root of 16, we take the square root of 9 first, which is 3, then the square root of 16, which is 4, and 3 plus 4 is 7. So we have a situation where the square root of a sum is not equal to the sum of the square roots. So that's something to keep in mind as we work with these types of problems. So here's an example to try. Try these problems and then turn off your, pause the video, and then come back when you finish these problems, and then we can check our answers. So here we have the square root of 100 is 10, because 10 times 10 is 100. The opposite of the square root of 4 is equal to the opposite of 2, or -2. The square root of 1/16 is 1/4, because 1/4 times 1/4 is 1/16. Square root of 64 plus 36, we add first. That's the square root of 100, which is 10. And in part E, we take the square root of 64, which is 8, plus the square root of 36, which is 6, and 8 plus 6 is 14. So working with square roots, we can also make some observations about when we evaluate square roots, is that if we have the square underneath the radical symbol, we're actually taking, we want the positive square root. So we're actually taking the absolute value of what is ever the number that's being squared. So the square root of 3 squared we can write as 3, and the opposite of 3 squared is 9, so that's like the square root of 9, which is 3, Or, using this rule, if I have the opposite of 3 squared, the square root of that number is the absolute value of -3, which is 3. So we can use either square and then take the square root, or we can use this absolute value definition of the square root of a squared. Another thing we can do is we can use what's called the product rule to simplify square roots. So if I take the square root of 16 times the square root of 9, that's going to be 4 times 3, which is 12. If I take 16 times 9 first, that's 144. So the square root of 144 is also 12. So this shows me that we can use this property that either the square root of a times b is the square root of a times the square root of b, or vice versa. If I have the square root of a times the square root of b, that's the square root of a times b. So I can take the product of the radicands, the numbers underneath the radical symbols, to evaluate the product. So here we have some examples. We can use this product rule to help us simplify square roots. And a square root is simplified when the radicand, the number underneath the square root, has no perfect square factors other than 1. So for example, if I want to simplify the square root of 300, the largest perfect square factor, so if I think 1, 4, 9, 16, 25, 36, 49, 64, then 9 squared is 81, 100, 121, 144, 169, and so on. Those are squares. It might be good to list those. And the largest perfect square factor that 300 has is 100. So we can think of 300 as 100 times 3. And using this property, we can say that the square root of 100 times 3 is equal to the square root of 100 times the square root of 3. And the square root of 100 is 10, so we have 10 times the square root of 3, and that's simplified because the radicand is not a perfect square. So once we get down to a place where we don't have a perfect square, then we have a simplified radical. So in part B, we're using this rule. So the square root of 4x times the square root of 2x is the square root of 4x times 2x. So we can write the product underneath the radical. That's 8x squared. And 8 is 4 times 2. Okay, so 4 is a perfect square, x squared is a square, and we have a square root of 2. So if I take the square root of 4, that's 2. The square root of x squared is x times the square root of 2. And so this is simplified because 2 is not a perfect square. And if, in order to take these square roots, these numbers, these radicands have to be positive numbers. So what's happening here is x must be a positive number. So when we take the square root, we just say x. We're assuming that x is a positive number here. So try these two problems, pause the video, and then come back to check your work. So the square root of 48, the largest perfect square factor in 48 is 16. So I wrote 48 is 16 times 3. By the product rule, I can write that as square root of 16 times square root of 3. And the square root of 16 is 4. So this simplifies to 4 root 3. In part B, we can multiply the radicands, and we get 72x squared. And the largest perfect square factor of 72 is 36. So if we take 36 times 2, we get 72. And so we have 36x squared times 2. And by the product rule, we can rewrite that as a square root of 36x squared times square root of 2. And the square root of 36x squared is 6 times x. So we have 6x root 2 as a simplified form of that radical. There's also a quotient property, or a quotient rule. So if we have the square root of a over b, we can write that as the square root of a over the square root of b, or vice versa. If we start off with square root of a over square root of b, we can write that as a fraction as a radicand underneath the radical a over b. And as long as b is not equal to 0, we'll be able to work with these expressions. So here the square root of 81 over 4, we can write as the square root of 81 over square root of 4, which is 9/2. And if we start off with the square root of 75x squared over square root of 3x, we could write that as one fraction underneath the radical. That's the square root of 75x squared over 3x. So that's the square root of 25x, which is the square root of 25 times the square root of x. 25 is a perfect square. So we can write that as 5 times the square root of x. So try simplifying these. Pause the video, and then come back when you're ready to check your work. So square root of 16 over 25, we can write that as the square root of 16 over the square root of 25. The square root of 16 is 4, the square root of 25 is 5, so that's 4/5. And square root of 150x cubed over the square root of 2x, we can write that as one fraction underneath the radical symbol and simplify. So we get 75x, and the largest perfect square factor in 75 is 25, so we can write that as 25 times 3x. And then we can use the product rule to break up the radicand. We can say that square root of 25 times the square root of 3x, which is 5 times root 3x. So if we have higher roots, if I want to talk about the nth root of a number, that's the nth root of a. And the number n is called the index of the root. So if we take the nth root of a and get b, that means b raised to the n power gives you a. And if n is even, the radicand has to be a positive number in order to evaluate it. And if n is odd, a and b can be any real number. So if I take a cube root, for example, a could be -8. But we can't do that if it's even. So if n is odd, the nth root of a to the n is a, no matter what sign a is. If n is even, then the nth root of a to the n is the absolute value of a. So the cube root of -2 cubed, 3 is odd, so the nth root of a to the n is a, so that's going to be -2. And the fourth root of -2 to the fourth, well, that's going to, 4 is even, and -2 to the fourth will be a positive number. So we can do that, but in order to do that, we can take the absolute value of -2, which is 2. And the product and quotient rules for square roots apply to higher powers. So we can use the product and quotient rule as we were using back in the prior objectives of this lesson. So if we're simplifying the cube root of 40, we can say I can look for the largest cube root factor of 40. So cubing numbers, I have 1, 8, 27, 4 cubed is 64, 5 cubed is 125. And usually knowing those first 5 are helpful. And so the largest perfect cube factor of 40 is 8. So we can write 40 as 8 times 5. And that will be the cube root of 8 times cube root of 5. The cube root of 8 is 2, so that's 2 cube roots of 5. And if we take the fifth root of 8 times the fifth root of 8, that's a fifth root of 64. And then I know 2 to the fifth is 64. So if 2 to the fifth is 32. So 32 times 2, I can write 64 as 32 times 2. That's a fifth root of 32 times the fifth root of 2, which is 2 times the 5th root of 2. So we're using the product rule there. And then the cube root of 125 over 27, I can break up the quotient here and say that's a cube root of 125 over the cube root of 27. The cube root of 125 is 5, since 5 to the 3rd power is 125. And the cube root of 27 is 3, since 3 to the 3rd power is 27. So that gives us 5/3. So try simplifying these three expressions. You can pause the video and then come back when you're ready to check your answers. So in the first problem, the largest cube that's a factor of 24 is 8. So I rewrote this as cube root of 8 times 3, which is cube root of 8 times cube root of 3, which is 2 times the cube root of 3. In part B, if I take the 4th root of 8 times the 4th root of 4, that's a 4th root of 8 times 4. And 8 is 2 cubed and 4 is 2 squared. So this is 2 to the 5th, which is like 2 to the 4th times 2. And the 4th root of 2 to the 4th is going to be 2 times the 4th root of 2. So I wrote these numbers as powers of 2 to get exponents here, and if I have an exponent that matches the index, like that rule above, the 4th root of 2 to the 4th is 2. And in part C, we can use the quotient rule. So the 4th root of 81 over 16 is a 4th root of 81 over the 4th root of 16. 3 to the 4th is 81, and 2 to the 4th is 16. And the 4th root of 3 to the 4th is 3, and the 4th root of 2 to the 4th is 2. So we get 3/2. So what you want to do now is practice these types of problems. You can work with the written practice on this learning guide and do the online assignments, and we will see you in class.